Hello guys! Today we're gonna test an English version of our explanation of problems. Okay, without further ado, I would like to tell you about the problem number 2 from the project 4, where we have a difference scheme for advection equation in the following way, and we need to analyze it. Where theta is a parameter from 0 to 1, and we will define it a little bit later, how it's connected to our stability region. Oh, this marker sucks. It's a little bit funny to speak in English because I know so much bad words and they're less bad than Russians. Okay, and first we need to analyze consistency of this scheme for advection equation, and small remember for everybody that advection equation is du over dt plus some, oh, not advection equation, diffusion equation. Yes, we have diffusion equation with coefficient 1 or the speed 1, and we want to use the following scheme for this equation. And if you notice that when theta is equal to 0, we have exactly our FST forward time central space scheme, which I have already discussed previously. It's when theta is equal to 0. But we want to explain this for theta in region from 0 to 1. And I need to change my marker. And let's check. Maybe red one. Okay, first we're gonna check consistency. And for that, we're gonna say that we say that our function at position xj plus r times dx, and at time n plus k delta t, delta t, I don't know how to say it in English, I'm sorry, will be in operator's notation in the following way. Это вообще видно? Ладно. Когда перестанет быть видно, мне нужно будет сказать. Okay, let's continue. And now we want to substitute it to our initial scheme. Maybe. Oh, this marker much better. We found it. The best candidate for our video. Okay, substituting, and we can immediately cross the function ujn, because then we will use only operators. So what we will get in the end? We will get in the end the following. E times dt over dt minus 1 minus theta e to the power minus dt delta t over 1 plus theta delta t is equal to, well, I have already crossed the ujn, and on the right hand side we have exponent to the power minus dx over delta x plus minus 2, and plus exponent to dx over delta x with the plus sign, and divided by delta x squared. And then we need to write explicitly what is exponent for delta dt delta t and dx delta x. So let's write it, and we get, well, I believe we need to the second order. Well, I believe everyone can continue this line. And this is equal to, and on the right hand side we have exponent with a, which in power goes the minus and plus, and you can see that the odd powers will cancel out, so therefore we can keep only even powers. So that's why here will be dx over delta x squared plus 1 over 12 dx delta x to the fourth and plus O big of delta x to the sixth power divided by delta x squared. And now we need to remove what's written on the top. We're gonna make this much faster in the video. Okay, doesn't matter. Okay, after simplification, of star, and let's denote by star exactly this relation. We get the following: delta t minus delta x squared plus 1 minus theta divided by 1 plus theta dt squared over delta t divided by 2 plus dt, oh, it's so delta t squared divided by 6 minus 1 over 12 dx to the fourth derivative times delta x squared and plus O big of delta t cube and dx to the power 4. And it is equal to 0. Well, and we can notice that when dt and delta t and delta x goes to 0, our scheme, well, let's denote it by 2 stars. 2 stars goes to dt minus dx squared equal to 0. So that means that our scheme is consistent, and the second check for consistency is that we don't have any fraction in way like delta t over delta x or delta x over delta t, and we can see that there's no such term. So that's why our scheme is consistent. And next, we need to say what is the leading error term. And for delta t, well, let's first for delta x. For delta x, it's clear that the leading error term, and I want to use maybe red one. This is leading error term. I'm not sure that you can read leading error for dx, for delta x, and it's a second order. But for delta t, we have two choices: either choose the first order or second order. And usually we go with the first order, but in case when theta is equal to 1, this term goes to 0, so we have second order. So there's like two cases. One theta equal to 1, and from here it will be delta t order. And second case, today we don't have fancy board, unfortunately there is some class, and if theta is not equal to 1, we have, if theta is equal to 1, we have delta t squared order, but if theta is not equal to 1, we have delta t error, delta t order. So that's all for consistency, and here we have maybe fast episode. We are back. Okay, now we need to check stability. And for stability, we're gonna use von Neumann. We say that Ujn will be e to the power I k xj times sigma n, and then when we substitute it back to our scheme, we will get something like that. I will better use my notes because I can miss something. Now we divide by sigma n to the e x k j, and what we get is
sigma squared minus 1 minus theta sigma minus theta divided by 1 plus theta delta t is equal to, well, it's maybe better to write it first like that.
Now I want to simplify the right hand side. You see, if you have two exponents and you can make some cosine or sine function, and here it will be cosine, and actually it will be 2 cosine of k delta x minus 2 divided by delta x squared. And I forgot that we divided not by n, but n minus 1. And here we will keep sigma, because here we have sigma to the power n minus 1. And now I will continue simplifying it as a half angle. So that's why it will be minus 4 sine squared k delta x divided by 2 times delta x squared and multiplied by sigma. So now we have simplified it, and what we need to find sigma such as the absolute value of sigma is less than 1 for stability. Let's do that. We will transfer the denominator to the right hand side and then simplify everything, and eventually we will get something like that. Sigma squared minus 1 minus theta c, then we move this part to the left, plus c divided by delta x squared multiplied by 1 plus theta delta t sigma, and times sine squared. And minus theta equal to 0. Well, now I want to say that dt over delta t over delta x squared is r. But also I want to say that my sine squared is a. Since sine takes values from minus 1 to 1, and sine squared will take values from 0 to 1, so a is positive. This will simplify to the following. Sigma squared minus 1 minus theta sigma plus 4 1 plus theta times r times a times sigma minus theta is equal to 0. And now we need to find sigma, and this is a Kierkegaardian equation, so let's solve it. Sigma will be equal to
1 minus theta minus 4 1 plus theta r a plus minus this big guy in squared. Well, in squared. And plus 4 theta. And divided by 2.
Well, it's sigma 1, 2. And we need to analyze for which values of r and theta, I don't know how to say it in English, sigma is, the absolute value of sigma is less than 1. So let's first consider when we have sigma 1, which, well, actually we can consider both at this simultaneously, sigma 1 and sigma 2, with how it depends on A. And I want to say that it monotonically depends on A, and to prove it, the most easiest way for me to differentiate, let's consider the derivative of sigma 1, 2 by value A. So what we will get that it's minus 4. And we can see that actually if we factor out minus 4, well, minus 2, we divided by 2 everything. And here will be 1 plus minus, well, this is very important part. And here's square root, it will be the same as this one, but also with plus 4 theta.
So that's why we will have an interesting conclusion. Squared plus 4 theta. So
since we add to the square root 4 theta, our square root, our denominator, will be always bigger than numerator. Numerator, I don't know, the denominator. That's why this value, well, I will try to.
oh shit.
It will be always less or equal to 1 by modulus. By modulus than 1, because again denominator is bigger than numerator, and that's why the whole bracket will be always positive, and that's why this whole bracket will be bigger than, well, it will be positive, and that's why the whole equation will be always negative, because here we have minus 2 times 1 plus theta times r, and we know that theta goes from 0 to 1, and r it's dt over dx squared, and it's always positive. So all that was to prove that our sigma, well, let's write it. We are back. So this was to show that our sigma 1, 2 decrease as our A, which is sign, increases. And also what we can notice that sigma 1 is always positive, not negative, maybe it's correct to say, and sigma 2 is non-positive, because, well, you can prove it the same way as here. So that's why the maximum value for sigma 1 will be at the minimum value of A, and the maximum value of the absolute maximum value for sigma 2 will be at the maximum value of A. And from here we get that sigma 1 max will be sigma 1, maybe max, because there's another parameters, at A equal to 0. And when A is equal to 0, it's very easy to calculate. It will be 1 minus theta plus square root of okay. Yes, and it's and we are good. And for sigma 2, we need to analyze it a little bit further. So let's consider sigma 2 now, and I also need to clean a little bit my board. We have a small problem here, but I will clean it later. So for sigma 2, what we have? We have that sigma 2 max is actually at the highest value of A. Sigma 2 max when A is equal to 1. And what is it? So since we know that sigma 2 is negative, and we need to check when our sigma 2 max is less or equal than 1, so it's the same as minus 1 sigma 2 max 1. So I need to consider only this case because I know that my sigma 2 is negative. So because this one is always satisfied. So that's why I will drop the absolute value and write it and we need to check when it's less or equal than 1. And here you can do the following. You can solve when it's equal to 1 to minus 1 and make substitution. I want to say that this is equal to z, and then I will get something like z minus square root of z squared plus 4 theta is equal to minus 2. Then I solve and I acquired that. Let's make it like that. And from here, it's clear that and that will be equal to theta minus 1. Yes, that's correct. And from here, since theta is equal to 1 minus theta minus 4r 1 plus theta, you get your r. It follows that r is equal to 1 minus theta divided by 2 1 plus theta. And now, since we solved when it's equality and we need inequality, you can check it and you need these values. So this is the answer for your problem. Thank you very much. If you have any questions, write in the comments, subscribe, and enjoy your life.